Welcome everybody to Games of Go. This is now episode 32, and tonight we're going to finish up the visibility code to make our dungeon actually dark and only let us see where it makes sense for us to see based on where the player is. If you're new to the stream, or if you've been following along for a little while, you can get access to the source code each day, either by subscribing through Twitch, which you can do for free if you have an Amazon Prime account, or you can go to the homepage, the Games with Go homepage, and I'm putting a link in chat, gameswithgo.org, and you can donate with PayPal there if you'd rather not subscribe through Twitch. Either way, you get access to the GitHub repo, which has a release for every day of the Games with Go episodes. So you can get the source code in the state it was for any given episode in the past, present, or future, eventually. Okay, so last time we left off, we had implemented our Bresenham line algorithm and attempted to use it to set our visibility in the dungeon. But we had some problems. It's not working yet. And one of the reasons is because for some of the lines we draw, if they go in the right direction, we're doing this swapping trick to avoid having to implement this part multiple times. And when we swap this way, in this case, where the start x is greater than the end x, so the line's going from right to left, basically, we're reversing the order of our points. Our points end up going from the thing we're looking at to us, and we need it to go the other way. So there's a couple things we can do that will fix this problem and as well make this more efficient. So one of the things I talked about last time is that we are allocating memory to store our results every time we call this. And we're going to end up calling this quite a bit because wherever we are on the map, we're going to need to probably need to calculate the visibility from every point that's potentially within our visibility radius, calculate the line to that point to see if we can see everything along it or if we can see to that point. So that's going to be a lot of lines, so we don't want to have allocation happening every single time. So it turns out we can actually get rid of this if we make this function less generic. And as programmers, we tend to always want to make things as generic as possible. We're taught that a lot, and oftentimes it is a good thing to do. But sometimes if you make things less generic, they can get much simpler and or faster. So we're going to do that here. So currently, this is like a general purpose Bresenham line algorithm that we could use anywhere. Just give it a start and an end, and we get back a list. But we're going to make this special purpose because we need it to be quick, and it'll make it simpler too, which is a bonus. So instead of returning a position, it's just going to go ahead and directly mark visibility in the dungeon. And so we can do that basically in all these spots here. Instead of appending to the result list, we're going to just set the visibility of the level. So this will need then to be a method on a level. So this will have a pointer to a level as a receiver. And then with that, we can do this. We can get the map directly, get the position Y, and just set the visibility to true. That's going to be, let's pull that down here. And we're going to delete these appends. We're going to make an uninitialized position variable and then set it in here. So it'll either equal y comma x in the steep case, or x comma y in the not steep place, and then we'll set the position there. And then remember though that we need to not set visibility if we run into a wall. So what we're going to want to say is if we can't see, then we're going to want to break out of this loop, or actually return from the function entirely. Because what we're doing, remember, is like we're, for any given point, say the player was located here, and we want to see if this tile is visible. We draw a line from the player to that tile, and we say, okay, this is visible, but this is not, because this was a door. So as soon as we hit something that's not visible, we can break out and stop marking things as visible. Where were we? If anyone has questions at any time, just put them in chat and I'll check in when I can. Okay, so did we implement? Yes, we did. So I'm just checking to see if this still makes sense. So one thing we need to do is check to see if we're in range here for safety. So we made an in range function that just makes sure that the position we're given is actually within our map, that we're not trying to go outside the bounds. And if we're not in range, then we'll say false. I think that's good. So go back to Bresenham. All right, there you are. Okay, so if we cannot see through, then we'll just return. Okay, so that takes care of simplifying things and making it perform better. We don't need to return result anymore. There is no result. But it's still going to be doing things in the reverse order when we're swapping things this way. So what we're going to do is, instead of trying to do this code only once, we're actually going to do part of it twice. So I'm going to start out just copying and pasting this whole thing here. Well, actually, we'll do an else here. So all this line drawing logic, we're going to start out with a big copy paste. And instead of swapping, we're just going to do this with its own logic. So delta x is going to be start x minus index, because we want a positive delta, and start x is bigger than index. Delta y will be the same, error is going to be the same, this is all going to be the same. This is going to count backwards. And this is how we're going to avoid having our points end up in reverse order, because we're still going to start at start x, but then we're going to count down instead of counting up. So I think this logic will all still be the same. Yeah, so this should all still be the same. Okay, so now we have a big copy paste of repeated logic, and some of it doesn't need to be. I think we can pull out, I think all of this is identical in both. So I'm going to pull that out so we're not repeating ourselves too much. Pull that out into there. And then we don't need any of that. And then you could like pull all of this out into a shared function or something to avoid repeating yourself, but I think in this case that's not warranted. It actually would make the code harder to follow in some ways, because you would have to, you're looking through this function to see how it works, and when you get here you then have to pop up to another function, and that can be confusing. So I'm going to leave it like this for now. If this were to expand later, we might change our minds about that. Okay, so this should fix the problem of Bresenham being reversed in that one case. Now we got to fix up the code that calls it, because now we don't need to get a list of things. And we don't need to do this. We don't need to set visibility to true based on our result because we don't have any result. So that can all go away. And this now is part of level. So we got to call it on level. Okay, so what else do we need to do here? Okay, so let's see if this changes our test case here. No, why not? Let's see. Let's bring back that debug print we had. Oh, I think it doesn't run until we move. That's why. Okay, there we go. Yeah, so now we're drawing lines straight up, and we were killed by spiders. Let's actually get rid of these spiders so we can test without being murdered. Get rid of our extra player too. Who knows what chaos that will cause. Okay. So that's good. The vertical line is now working and showing visibility. So now what we need to do is not just draw one visibility line, but we need to draw visibility lines for everything, everywhere where we could potentially see, which is going to be a radius, be a circle of some size based on our sight range. Remember, we have a sight range as part of our player. So let's make a function that does all of this. We can put it right. F12 does not always work. Okay, so we can put it right near Bresenham because they're going to be related. And we're going to call this line of sight. And it's going to compute which points are visible for the player using our Bresenham algorithm. So let's start out. We're going to want the player's position. And then we're going to want the player's sight range. And then there's different ways we could do this. I'm going to do it the simplest way, which is we're just going to iterate over a square of that distance. So, and this is a radius of the circle, not a diameter. So we're going to go from position.y minus the radius less than or equal to position.y plus the radius. And the same for x. Okay, so we're going to iterate over a square that is the size of the radius. And then we're going to compute the distance to each point. Which is square root of x delta squared plus y delta squared. And this is something that might be part, if we had a two-dimensional vector library, we might have a distance function built in. So if we find ourselves doing this again, we might want to go kind of start a two-dimensional vector library. And I think that's likely if you were to turn this into a big game that you would run into this again. So to see if we're in the circle, we just see if the distance, d, is less than or equal to the player's sight range distance. And if it is, then it's possible that it's visible. So we'll check for sure if it's visible by calling Bresenham on it. And what's unhappy here? Okay, so this is going to iterate over a square the size of the player's sight range. And anytime it fits within the circle, we call Bresenham to see if the thing's visible. So it's going to iterate over every tile around the player within that radius. And that's not too much work. Remember that Wolfenstein 3D ran on ancient computers, drawing many more lines than that. Okay. Is that all we need to do? So every time we move, we'll need to call line of sight. And then when we start up, we'll want to call it as well. So probably when we load level from file, I'm going to call it once at the end. So you start out able to see. Let's give it a try. That's looking good. Let's see, can I move? Okay, that's promising. Cool. Okay, so looks like the problem we've got, though, is that we're not clearing what's visible every move. So things are remaining visible forever, which is not how we want it to work. So let's clear that out. How should we do that? Where should we do that? No, we are setting visibility equal to false. Oh. Are we checking in here? Okay, if tiles, we only draw it if the tile is visible. That's correct. Let's see, why are we still drawing stuff that should no longer be visible? Are we not clearing? No, we're clearing here every time we draw. We're making sure the tile is visible. Oh, I think I know what's wrong. Yeah, so this is a problem of pointers and values. So this is a copy of the tile. It is not a pointer to the tile. So we're changing the copy to be not visible, but not the actual tile inside the map structure. So to fix that, we can get the index, ignore the tile, and then get level.map. How do we do this? It's a map. Oh, we don't even need the I. Oh, we need the X. So this is X. This is Y. YX dot visible. Give it a try. There we go. So now we're only seeing inside a circle. So I'm going to make it a little smaller. Where is our player's sight range? Sight range 10. Let's try making it 7. Be a little easier to debug. All right. Now, one thing you might notice is the floor tiles and stuff are like changing randomly. It's not really making sense. So the reason for that is we are seeding our random number generator right here, which means as you call rand, which we're doing right here, as we get our random numbers, it'll give you the same sequence of numbers when you call it. But now we're not always calling it the same number of times because that call to random is inside this if statement about whether the tile is visible or not. So we need to pull that out so that it's always calling rand the same number of times. Whether or not the tile is visible, you're still going to call that random function. So this whole thing, I think, or just this. These two guys need to come out so that we're calling that every time. Actually, we only want it if. So we're going to have a couple if statements here. So we can take this out of here. So if it's not blank, we're going to compute these source rectangles that we're going to use with our random number. And if it's visible, we're going to draw it. And now our map stays constant as we move through it. And then we should see if we open a door. Aha! So we got a problem there. We opened a door and we didn't get our visibility. We had to move first. So the reason for that is currently line of sight, which is our function that figures out the visibility, is only called when the level loads and when we move. And when you press forward on a door, you don't move. You just check the door. So what we should do, anytime we're changing the state of a door, check our line of sight again, adjust our visibility. So now as soon as we open it, we can see. Open it, and we can see. All right, now there's one other aspect I want to add to this, which is if you've seen a part of the dungeon before, once you move out of it, you should still be able to see what the walls and floors look like. Like your player would have a memory of what was there. You don't have to implement it this way. You could choose to actually, force the player to make their own map on a piece of paper or something. But we could show where the player has been and just mark it, draw it faded out a little bit so that it is clear that you can't see what's going on those tiles right now, but you know what the shape of the room is. So that if you're over here, you'll still know what this stuff looks like, but you won't be able to see if there's monsters there. Anything that's been changing, you won't know about it because you can't actually see there right now. Which is sort of like Fog of War in RTS games. So let's add to the level. To the tile. So we have a visible Boolean. So we're going to add one. We're going to call it seen, which indicates whether or not you've seen the tile before. And basically, anytime we set something to visible, which happens in here, we're also going to set it as having been seen. So we'll do it there and there. And then this, we won't clear out every time. It'll stay true for the rest of the game. And over in UI. So now we've got another option here. If it's visible or seen, we're going to draw it. But if its scene, we're going to set a color mod. So we're going to do something like let's see. This should make it halfway faded out. And then this needs to be seen and not visible. Then we'll draw it gray. Otherwise, we'll draw it full. Let's give it a try. 2 errors. So we got to set the scene to false when we create a tile. All right, there we go. So now you can sort of see your memory of what the level looked like when you've been somewhere. Okay, so one problem we have is the monsters are being drawn grayed out too. So let's fix that. So basically this, we need to set the color mod back to white once we start drawing the monsters. This is our loop that draws all the monsters. And we don't draw a monster unless the tile is visible. It doesn't matter if you've been there before, you have to actually be able to see it right now. Otherwise, no draw. There we go. Now they look correct. All right, so we've got the feature working now. It works well. We can see things on a diagonal through doors and stuff. It does look a little bit rough. Like you might not like this look where it shows just entire blocks are either visible or not. And there's a couple ways. I'm not going to do it tonight, but there's a couple ways you can make it look nicer. One way is you could make a texture that has like complete transparency in the center, and then as you get out near the edges, it starts getting darker and darker. So then you would have a nice smooth circular transition from visible to invisible, and you could just make it, you know, fit within the edges of this so you don't see any of the big tiles. So that's one approach, and that's pretty easy to do. You just make that one texture. You can use some math to draw it, or you could draw it in a paint program, and you just put it on top of the center of where the player is, right, where the alpha is totally see-through and then darker and darker and darker. Another way is the tile set we have has some tiles that look like they're kind of made for this purpose. Some of the ones like this, like I'll draw it, highlight it in red in case you can't see my mouse. But some of the ones like this, they have like kind of a fog or this group right here. So what you could do is use these anywhere along the edges of your visibility. So it looks like it's actual fog that's being revealed as you walk through the level. And that would probably look pretty nice as well. Or you could do some combination of those two things. So those are some options to make it look nicer if you wanted to. And I think for now though, what I'd like to work on next is making a way for levels to link together, right? So right now we have one level, and we could make it arbitrarily large, which is cool, but I'd like to be able to make like a staircase or portals or really anything you want, and when you step on it, it'll take you to another level, so you could have multiple ones. So let's do some things kind of to get ready for that. Let's first make a second level. I'm just gonna copy pasta. By the way, if there's any questions about the visibility stuff, fire away in chat. I'll be checking in. So I'll just make it level 2 for now. We'll start with like a down staircase as the concept here, and we'll do something different. We'll start out with just a simple proof of concept room. And so then we'll need some kind of indicator, like a staircase or a portal of some kind. So let's see, we have got staircases here. Got a couple different ones. This one looks like it's meant to be drawn on top of another tile, which is cool. It's got alpha on it. Let's go with this one. So let's see, we need to put this into our index. We'll have this is a down staircase. Is there an up of the same kind? There's this one. That looks a little different. Doesn't match. Oh, let me undo my red. There we go. Let's just do these two then, since they match. But you can do whatever you want, ye who are following along at home. So I'm going to pick these two. So let's see, let's do our math, our advanced calculator. So this is at 1718. 713, so 53. And the Y 370, that's a down staircase. Should be able to do that in my head, huh? 11. And there's just one of them. So that's a down staircase. So we'll say lowercase d. And the up staircase should be the next one over. Okay, so what do we do next? We need to represent those tiles somehow. Move those up here. Okay, so we got up and down. And I guess since these are, well, no, that's going to need to be on top of the floor as well. So I think what we'll need is like a separate category of things to draw that will be overlaid on top of the floor. What do we call that? Or we could make tiles have multiple things. We could do that with doors as well. Doors could be on top of the floor, so they would draw through. Let's try that. We'll see how it goes. So we'll do an overlay rune for every tile. And so when we load a level, so we can do it for doors first to try it out. So instead of rune being set to door or closed door, we're going to set the overlay rune, and the actual rune will be pending, just like we do for monsters and players. And then since we've set it to pending, we already have the logic that will set the actual rune. And then so by default, overlay rune will equal blank, because most things will not have an overlay rune. Okay, so I'm not even going to do stairs yet. We're going to test this overlay idea on the closed and open doors to see if it works like we want it to. Okay, so that might be it for the game. So now we just have to render these sorts of things. So this does all the work of rendering the tile, the rune. So I think what we need to do is just say if tile dot doesn't know about this yet. Have we saved? Oh, here's a couple errors. Okay, so we got to set the overlay rune in here as well. So that'll be blank when it's just a floor. And now we should know about overlay runes now that we've saved it. We did capitalize it, right? Where's our tiles? Yep. There we go. Had to save that one. Okay, so if that's not equal to blank, then we need to draw it as well. So we need the same logic for source rectangles. We're not going to need the randomness, maybe ever, probably ever. We can make that a constraint. Put it to do here. To do what if there are multiple variants for overlay images. Because that could happen, right? We could have multiple doors that look a little different for variety. But for now, we're not going to handle that. So this will just be actually this with 0. And then that's all we need to draw it. We just got to copy it on. Oh no, we need the destination rectangle as well. I guess actually we can reuse the destination rectangle. That's the same, since it's an overlay. Okay, so if this works, we should be able to see behind our doors when we open them now. Let's give it a try. Come on, rats. Oh, now there's no door at all. Let's see if we're getting in here at all. And let's get rid of this yep. Yep and nope. Okay, so we're never seeing an overlay. Overlay is always blank. Why? So this should be in load level from file. If we're a door, we're setting the overlay rune for sure. Maybe, this is why. So this is resetting the whole thing, not just setting the rune. So what we should probably do is make this just return a rune. And then we can just return that rune, I think. This makes it much simpler. Oh, no. Only if it's a dirt floor. Return a dirt floor only if it is a dirt floor. So if it's dirt floor, return dirt floor. Yeah, and if we don't find anything, we just return a dirt floor. For now, this is the only type of floor we have. In the future, there will be more types. We want to find, this is the function that finds the closest floor tile to something that's got a character or monster on top of it in the level map. So now, you just set the rune. That should fix it. False. Why not? The overlay rune. Let's just make sure we're if anyone in chat sees it, let me know. Oh, wait, we actually never, no, setting overlay rune. Okay, we are getting the overlay. Okay, good. The bug's different now. Progress. So we're just not drawing it. We're getting the wrong texture index. Source rectangle. Oh, of course. We need the overlay rune when we're looking at the overlay. So we were just drawing the floor twice. Easy fix. Okay, there's the door. And our check door function is now incorrect. This is why programming is hard. So this should be looking at overlay runes now. Okay, so here we're kind of seeing a problem with this approach, which is it's complicating lots of other logic, right? Like we wanted to know, like here we're checking to see if there's a closed door, and now we have to check separate cases. Which is kind of no good. We're gonna have the same problem though if we do this by having doors and stairs being totally separate entities though. All right, for now I'm just going to deal with it. Sometimes you just have to deal with it. I'm going to think about whether there's a more elegant way to do this. Maybe next time I'll think of something better. But for now, we'll give this a try. Okay, we're still probably failing to identify that we need to check the door. Possible that we could abstract these checks into a function that does this properly every time. That was always true, so we always return false. All right, there we go. There we go. It's working. So now we can see behind the door is still a floor. So that's an enhancement. I like it. So let's add some stairs. Okay, we added stairs here already, so we just need to add it here. Upstairs. Pending. All right, so we should be able to draw them now. Let's put a downstairs there and an upstairs there. All right, we've got stairs. Drawing at least. So the next step is going to be to have a way to link one tile, like that stair, to another one. Say the upstairs there. Let's do an upstairs also, just to test that that draws correctly. Oh shit. No. Anyone in chat know how to undo a git checkout -f? Oh, probably can't. Oh, I can undo. Can do that here too. Yeah. I think I just saved myself. think we're good. Oh, God damn it. Sorry, guys. Guess I should just never type that. Okay, we're back. Index out of range. Is that because of our U? Oh, I know what it is. Our atlas is gone too. Okay. So Peartree asks in chat if it would be advantageous to have full layers on the maps instead of a per tile. I think what you mean is like, wouldn't it be better if we had some sort of editor where we could indicate the floor tile and indicate the thing on top of it explicitly? And yes, absolutely, that would be the kind of thing you want to do. That's just going to be like weeks of development effort. So we're not going to do that on stream. But if you were wanting to turn this into a bigger project of your own, you might definitely want to build your own editor where you could have multiple layers and you could like navigate between them. So you could indicate that you want a certain dirt tile under your monster rather than just us having to like compute one and so on. So if that's what you're asking, yeah, absolutely. Okay, let's put our upstairs back in here. Okay, cool, that works. Okay, so next time what we're going to do is, along with our maps, we're going to have a new file. Call it, I don't know, world. Call it something. And basically all it's going to be is some comma delimited values where we can do something like level 1 and then some coordinate xy maps to some other level and some other coordinate. Right, something like that. And this will let us kind of build anything we want to build. So we could make a one-way passage, right? You could make something where maybe there's a hole in the ground or a trap, and you fall from level 1 down to level 2, and you have to find your way out. There's no way back up. So if that were the case, you would do this, but then not make the reverse, right? You'd leave this out. Right? Or if you did want it to be a two-way thing, like an upstair, downstair combination, then you could include both directions. And this could also include secret things, right? Like we're going to put some stairs and make a passage from level 1 to level 2 through the stairs. But you could also just make like secret traps that you can't even see. It could be anything, or a door. You could pick any tile drawn that you want to, and just have it when you hit that tile, you go from one level to another. So that gives you a lot of creative freedom with a really simple text format. You're basically with this able to implement a graph data structure, just like we did in the text adventure, where you can make any arrangement of things happen. So you can have any number of levels and link them together any number of ways you want to. That's kind of the plan. So we'll have to parse this, but the parsing is almost identical to how we're parsing our texture atlas. So we probably can maybe share some code between these two things. We're just parsing comma delimited files. So that's the plan. Any questions so far or thoughts about this episode or past episodes? Let me know in chat. I'll hang out for a few more minutes. It's starting to look a lot like Pixel Dungeon, which is a really nice free game on Android and iOS. I recommend it. It's hard though. It does procedurally generated levels. They all have like a similar theme and structure, but it's different every time. And when you die, you're dead. It's a roguelike. All right, looks like nobody has any questions tonight. So I will see you next time, which will probably be Tuesday. And we'll work on parsing this so that we can build entire worlds instead of just levels. All right, good night, everybody.